To find out more about nature's great storms, we have to learn more about the air around us. In this shot from space, you can see the moon and the thick blanket of air that surrounds our planet. It's called the atmosphere. It is an ocean of air dozens of kilometers deep. We live at the bottom of the atmosphere, and the amount of air that's above us presses down on us. We're so used to the air pressing down on us that we can't really feel it. But we can measure it with a device called a barometer. A barometer measures the weight of air in much the same way that a bathroom scale can measure your weight. The weight of air is referred to as air pressure, and air pressure is measured in units called millibars. This barometer shows that the air pressure is just under 1,010 millibars. That's how much air is pressing on the barometer and everybody and everything around it. But air pressure doesn't remain the same all the time. If you were to watch the barometer over a period of days, you would find that the amount of air pressure changes. That's because air pressure is influenced by a number of factors, including temperature. Here's why. In this demonstration, 2 blocks of air have been placed on a balance scale. Air, like everything else on Earth, is composed of molecules, shown here as tiny balls. Molecules are so small they are invisible to the naked eye, and they are shown much larger than they really are. These 2 blocks of air have an equal number of molecules, and that's why they weigh the same. But watch what happens when the block on the left is heated up. Its molecules spread out. There are now fewer of them in the same amount of space. The air rises because it weighs less. But when air is chilled, its molecules come closer together. There are now more of them in the same amount of space. The air sinks because it is now heavier. That's why a hot air balloon rises. The air within the balloon is hotter and therefore lighter than the surrounding air. Air pressure helps determine the weather. That's why most weather maps show areas of high and low air pressure. But weather maps have so many lines they can be confusing. So let's simplify one by removing all the lines except the ones that mark high and low air pressure. These lines shown in white. The areas with H's are high pressure areas. The area with an L is a low pressure area. Some of the boundaries between low and high pressure areas, here for example, can be windy. The wind is caused by the movement of air from an area of high air pressure to an area of low air pressure. You can simulate this yourself. When you blow up a balloon, you are actually increasing the air pressure within the balloon. The balloon now has higher air pressure than the air surrounding it. When you allow the air to escape, it creates wind, caused by the movement of air from a high to a low pressure area. Highs and lows are often associated with fronts. The red symbol represents a warm front. It's called that because it is a place where warm air is moving into and replacing cold air. The blue symbol represents a cold front. This is an area where cold air is moving into and replacing warm air. We've already seen that air's ability to rise is just one of its important properties. Another important property is its capacity to hold moisture. Just as a barometer measures the weight of air, an instrument called a hygrometer measures its moisture content. Air can be either dry or moist. You can't always see the moisture. It becomes visible only when conditions are just right. For example, during the formation of clouds or fog. Clouds and fog consist of water vapor that has condensed into tiny drops.